Now we are going to draw the graph of the derivative of this function. We know that the derivative is this slope function. So we need to look at the slopes of the tangent line at every one of these points on the graph. So for example, let's start with a place where the slope of the tangent line is 1. So let's see that. I think this is about right. So at this point where this line is tangent, this is the tangent line at this point, and the slope is about 1 because this is the rise over run. So it's 1, 2, 3, 4 and some over there, 1, 2, 3, 4 and some here. So let's make it one more accurately. I think this is about right. So at this point the slope of the tangent line is 1. So that means for this x value we need to plot, for this x value we need to plot y equal to 1. So that will be the derivative. This point would be a point of the derivative. As we move to the right, notice that the slope gets smaller and smaller, so it eventually hits 0 here. But because on the other side, let's see, because on this side the slope is not 0, so the derivative doesn't really exist at this point at 0. So but on the left side will be close to 0, and on the right side the derivative is the slope of that line. We will calculate that in a moment. So there is no derivative here. Now as we move to the other side of this curve, notice that the derivative gets bigger and bigger and bigger and bigger. So that means it's going to, at this point it's very close to a vertical line, the slope of the tangent. The tangent line is very close to a vertical line. So the slope is infinity. So that means this plot would be very high near this point. So there is a